Alright, so for today's notes, we're breaking it down into two parts. So we're going over trigonometric identities. So the hard thing about this is you have to think really creative because there's no right way to do it. It just depends on how you view the problem. So for our essential question we have was, what is an identity and what is the difference between simplifying and verify? So just a warning, so in order for you to excel in this unit, you have to be able to multiply and divide fractions. So I would say if you struggle with that, look back at the video that we talked about simplifying fractions. Alright, so the first thing that we're going to go over is what an identity is. So an identity is a special type of equation that is true for all x values. So kind of think about it if we were thinking in terms of not a variable, say like just numbers, so we know that 1 is equal to 1, so we know that's something that would always be true. So x would also always be equal to x. Like say 1/2 is the same thing as 2/4. So things about that, so something that's always equal to itself. And then one of the identities that you should be familiar with is your tangent. So remember, your tangent of x is always going to equal to sine of x over cosine of x. So this would be a good part where you can pause the video. So on your notes, make sure you make a section where it says quotient identities, and then around your quotient identities put a box over tangent of x, which is sine of x over cosine of x. And remember, tangent of x and cotangent are reciprocals, so then that's why here the cotangent of x is just the reciprocal of tangent of x. Alright, so here we have our first problem. So we have simplify to solve. So again, like I said earlier, these are going to be a little tricky because it just depends on what you see and how you can break it down. So what we want to do is we want to break this down until we can solve this problem. So here we want to think about our quotient identities based off the ones that we were given. Which one's going to help us simplify this down? So one of the quotient identities that we're given was tangent of x is equal to sine of x over cosine of x. So what we can do here is we can use substitution. So wherever we see tangent of x, we can replace that with sine of x over cosine of x. So now we would have sine of x over sine of x over cosine of x is going to equal to 1/2. So again, for this problem here, you have to remember the rules on how we divide fractions. So here I can change this into a multiplication problem as long as I flip the second fraction. So I can flip this to cosine of x over sine of x. So you want to think about, well, here, since I have sine of x in the numerator and sine of x in the denominator, I would be able to cancel those out, leaving me with cosine of x. So then I would have cosine of x is equal to 1/2, and then if you remember, this is a number that's in our chart, so now we can look at our chart to solve our problem. So if we look at our table for cosine, when it equals 1/2, we have here and also here. So now we're just writing down the radians for that. So the answer to this problem would be that x would equal to pi over 3 plus or minus 2 pi k, and also that x equals 5 pi over 3 plus or minus 2 pi k. Alright, so another pair of identities you have to be familiar with are your reciprocal identities. So again, in your notes, pause it right here and make sure you box this so that you can easily find them on your notes. So our reciprocal identities, we've already mentioned these before. So your sine, cosine, cosecant, cosecant, cotangent. So you can always substitute them with, like say secant, you can always substitute that with 1 over sine over u, and so on. Alright, so if you look at this problem, we really didn't go over how we solve in the table using cosecant. So we want to think about, well, based off the identities that I have, can I replace secant with something else? So we can. So based off our identities, we know that secant of x is going to be the same thing as 1 over cosine of x. So then here I'm just using substitution. So instead of having secant of x, I'm replacing it with 1 over cosine of x. So again, when we were solving these, our cosine was in the numerator. So what we can do here is we can use cross multiplication to get cosine in the numerator. So when we cross multiply, we end up with -2 cosine of x is going to equal to 1 times square root of 3, which would just give us square root of 3. And then we want cosine of x by itself, so we can divide by a -2. So then we get that the cosine of x is equal to square root of 3 over -2. So again, now we have something that we're familiar with. So again, this is a problem that was in our chart, so we can just look at our table again. So looking at our table for cosine, square root of 3 over 2, where we have it negative, is here. So look at our radians and also here. So then our answers for this one would be x equals 5 pi over 6 plus or minus 2 pi k. And then also x equals 7 pi over 6 plus or minus 2 pi k. And then just a shortcut for these problems. So earlier when we were solving this problem, before we started solving it, we had 1 cosine of x over -2 over 3. So a shortcut here is if I flip my first fraction, cosine of x over 1, I can flip my second fraction, square root of 3 over -2, which we would end up with the same thing because cosine of x divided by 1 is just cosine of x, which would give us square root of 3 over -2. I just wanted to show you the algebraic way. That way you know why this ends up working. Alright, so for this one, we're still trying to simplify and solve, so it doesn't say it in the title, but again, just make sure to write it. So we're trying to solve still. And let me fix this one real quickly. Alright, so again, for this problem, we want to try to solve this. So again, this is where I'm saying that it just depends on how you view this problem and how you want to approach it, because we have an identity for cotangent, we have an identity for cosine, so it's up to you how you want to break this down. So what I start thinking about is, well, my goal is to simplify this down. So if I were to change cosine, cosine is the same thing as 1 over secant. And then if we look at cotangent of x is equal to cosine of x over sine of x. So you have to remember is our goal is to try to simplify this down. So in order to simplify it down, the thing that we're substituting in it has to have something in common. That way we can try to cancel something out. So here our best choice would be to use the cotangent identity. That way we can try to see if we can eliminate something with those cosines. So then for this problem, if we substitute in our cotangent, we would have cosine of x over sine of x, all of that being divided by cosine of x. And we know that that's going to equal to a -2. So then just some side work. So remember, anytime we're dividing a fraction by another number, so here we can change cosine of x into a fraction. So we can change our problem into a multiplication as long as we flip this fraction here. So that would flip to 1 over cosine of x. And then again, just like that first problem we did, we have a cosine in the numerator and denominator, so we can cancel those out. So then we're just left with 1 over sine of x. So now we have 1 over sine of x is going to equal to -2. And just like the trick I told you before is for our fractions, we can flip these. So 1 over sine of x would change to sine of x, and then I can flip -2 over 1 to just -1/2. So now I have this simplify where I can find my value in the chart. So if we look at our chart for -1/2 for sine, so we have our radians for 7 pi over 6 and also for 11 pi over 6. So our answers here would be that x can equal to 7 pi over 6 plus or minus 2 pi k. And then also x can equal to 11 pi over 6 plus or minus 2 pi k. All right, so here we're doing another one. So just a warning, these are going to get progressively harder. So again, the hard part about this is being creative, knowing what to switch and how to switch them so you can simplify it down to just one trig function. So going based off our identities, if you notice what we're adding together, both of these have cosecant. So we want to think about for our identities, is there anything that has to do with cosecant? So we did have one for cosecant. We know that cosecant is going to be the same thing as 1 over sine. So again, our goal here is to cancel off something. So most likely we're going to cancel off sine. So what we're going to do is wherever we see a secant, we're going to replace that with 1 over sine of x. So for this first one here, we would have sine of x times 1 over sine of x plus 1 over sine of x times cosine of x equals 0. So if you look at this first one, we have sine x and sine x in the numerator and denominator, so those would cancel each other out, just leaving us with 1. And then here, if we were to multiply these out, I can put a 1 underneath cosine. So if we multiply our numerators together, we would have cosine of x over sine of x is equal to 0. So again, that one there should look familiar. So that's our cotangent identity. So we know that cotangent is the same thing as cosine of x over sine of x. So we can replace that. So then now we have 1 plus cotangent of x is equal to 0. So the next thing I can do here is subtract 1 to get my cotangent by itself. So we have cotangent of x is equal to -1. But again, we don't know how to solve for cotangent. So we want to think about, is there another trig identity that I can use to remove my cotangent? And there is. So cotangent of x is the same thing as 1 over tangent of x. So we can use substitution here. So we have 1 over tangent of x equals -1. And just a trick like before, I can change both of these into fractions. That way I can just flip them. So the tangent of x is going to equal to, if we flip -1 over 1, we'll just have 1 over -1, which will just give us -1. So now since we have this, we can look at our chart to figure out what our x values are going to be. So looking at our chart, when tangent is equal to -1, again, we only look up to pi for tangent. So we only have one answer. So we would have 3 pi over 4 plus or minus pi k. I know they're long. I'm sorry. All right, so the next identities that we're talking about are Pythagorean theorem identities. So just so that you know where we're coming these from, or these are coming from, is just from your unit circle. So this is back in unit 1. So we know that our unit circle had a radius of 1. And if y'all remember, our x and our y values, we're dealing with our cosine of x and our sine of x. So say here, if we were to try to use the Pythagorean theorem on this would be considered our a, b, and our radius would be c. So then we would have the cosine of x squared plus sine of x squared is equal to 1 squared, which would just give us 1. So that's how we get that. And then we're just manipulating the equation to solve for either cosine or sine. And that's how you get the remaining ones on there. So the same idea applies with 1 plus tangent squared of x is equal to secant of x. So here I can manipulate my equation so that I'm solving for tangent instead, which means I would have to subtract the 1 from both sides. So another equation you have to be familiar with is tangent squared of x is going to equal to secant squared of x minus 1. Or we can have where our two trig functions are on the same side. So I can subtract tangent squared of x from both sides, leaving me with 1 equals secant squared of x minus tangent square root of x. And then same thing applies with this bottom one here. So I can solve this for cotangent, which means I would have to subtract the 1. So again, don't write it out just so that y'all know what I'm doing. So we would have we'll write this down. So cotangent square root of x is equal to secant square root of x minus 1. And then we can have both our cosecant and our cotangent on both sides, which means I would subtract cotangent square root of x instead. So we would have 1 is equal to cosecant square root of x minus cotangent square root of x. So make sure on your notes you have all of these. That way you know how to manipulate them when you have to simplify or solve. Alright, so here's our next problem. Alright, so for this problem we are still trying to solve. So instead of using x, we're using t, but again, it still means the same thing. So again, we want to look at our equation and see, is there anything we can substitute to try to simplify this down? So going based off the Pythagorean theorem identities that we just went over, we can substitute our 1 minus cosine squared of t. So again, what we can do here is we can substitute in our identity. So instead, we would have 2.3 is equal to sine squared of t over sine of t. And again, if this is confusing you, what you can do is you can change these to y's like we did before. So this would be the same thing as saying y squared over y. So you want to think about, well, how can I simplify this down? So we have a y in the numerator and denominator, so one pair of y's would cancel out, leaving us with 2.3 is equal to y, which we know that y was representing our sine function. So then now what we want to think about now is, well, this problem here, if we look at 2.3 is not in our chart, so this means that we would have to solve this using our calculator. So if we were solving this using our calculator, again, if you don't like the format, you can flip it around, so we can have sine of t is equal to 2.3. So whenever we're solving this in the calculator, we would have to do the inverse of both sides. So then here we would get t, and then you run into a problem. So whenever you try to find the inverse of 2.3, your calculator might say error or something. So what that means is that this problem is going to have no solution since it's not falling within the range of our sinusoidal function. So even though this has no solution, I want to make sure that you're showing me all the work. That way I know that you came up with that conclusion. Don't just tell me no solution. I need to see the work. Alright, so for this problem, this one's just tricky because there's a lot of different ways you can do it. It just depends on how you want to do it. So the first way I thought about doing this one was changing this into its trig identities. So I know secant is the same thing as 1 over cosine of x. Tangent is the same thing as sine of x over cosine of x. And then the same thing would happen on the other side since you have the same things. But I think it might be easier to do it this way. So what we're going to do for this one is we're just going to let this equal y, and let's say this is w. So we have y plus w and then y minus w. So what we're going to do here is we're just going to distribute this out. Whoops. So we have y times y, that would give us y squared. Y times negative w would give us a negative yw. And then do the same thing with the w. So w times y, that would give us a positive wy. And then w times negative w would give us a negative w squared. So what's going to happen here is our two middle terms are going to cancel out since we have one that's positive and negative, leaving us with y squared minus w squared. And then, whoops, I forgot, for this problem we're solving, and we're going to set this equal to cosine of x. So then now what we can do for this problem is we can replace our y and w with what it was originally representing. So originally we had secant x squared, since our y is being squared, minus our w, which is tangent. So tangent squared of x is equal to cosine of x. So we want to look at our trig identities, and then, our Pythagorean theorem identities, and you would see that this is one of the ones that we have, which this is the same thing as 1. So we would have 1 is equal to the cosine of x. So now we would just look at our table. So for our table, cosine of x is equal to 1 when x is equal to pi over 2 plus or minus 2 pi k. So again, the first way that I told you to do it, that would have taken way longer than this step here. Alright, so here we have another problem that we're trying to solve. So again, the hard part about these is just figuring out what's the easiest way, which again, it just takes with practice. So what I like doing whenever I'm doing these problems is focusing on all the trig functions that they gave me and seeing if there's any relationship between any of those three. So again, if you think back, for cosecant, the only identity that we have is 1 over sine of x. So then we want to think about, well, for tangent and cotangent, is there any other identity that has them? And there is. If you think about tangent of x, there was one where we had sine of x over cosine of x. And then also for cotangent, we had one that was cosine of x over tangent of x. So sometimes what makes this easier is looking at all of them and seeing if there's a trig identity where they have something all in common. So then here we're just going to change this up. So for tangent of x, we would have sine of x over cosine of x plus cosine of x over sine of x is going to equal to, 3 over sine of x. So just with your fractions, so they had to have common denominators in order to add them. So just multiply by the denominator of the second fraction. So here I can multiply the first fraction by sine of x, the second one by cosine of x. So now I would have common denominators, sine of x times cosine of x. And then for my numerators, I would have sine of x squared plus cosine squared of x. That's going to equal to 3 over sine of x. So you always want to look if there's something that you can substitute in based off your identity. So here we have a Pythagorean identity, so that's going to be the same thing as 1. So we would have 1 over sine of x times cosine of x is equal to 3 over sine of x. And then here, flipping this is not really going to help us solve this. So what we're going to have to do is we're actually going to have to cross multiply. So we would have 3 times the sine of x times the cosine of x is equal to 1 times sine, which would just be sine of x. And I notice I have sines of x on both sides, so we can divide by sine of x. And also we want our cosine to be by itself, so we would have to divide by 3. So here our 3's would cancel out, our sines would cancel out, giving us cosine of x. And then these would also cancel out, giving us 1, but we have a 3 in the denominator, so our cosine of x would equal to 1 over 3. So if we were to look at our chart, we don't have this as an answer, so we have to plug this in the calculator. So we just have to do the inverse cosine. So we would get that x is equal to 1.23, and there's 0.9, so the 9 would round up, giving us 10 plus or minus 2 pi k. And then for cosine, remember our other value is just a negative, our principal value, so negative 1.2310 plus or minus 2 pi k. So I know these notes were long, but this is the end of it. So now we have our try-its. So I know these video notes are pretty long, but I just tried to give y'all as many examples as I could, just because I know this is a topic that a lot of students struggle with, just because it has so many things you have to substitute, you have to deal with fractions. So whenever you're submitting these into Canvas, I don't expect you to type all this in, so just be more efficient. Just write them out in your notebook, take a picture of that, and then submit the picture into Canvas. And also make sure to include your summaries.